Okay, I think we're about ready to get started. This panel is to look into the future, which is why that's there. And if you look carefully, the future, if you look up, is West Hills Kalinga Community College. Very subtle. We work on these things. But I think this is a great panel to follow on the earlier panels and actually all the discussions that have occurred earlier today, because you've heard about the workforce, you've seen students, you've heard about technology applied to food processing, manufacturing, you've heard about the issues of regulation, and there's been discussion about can technology help deal with some of those regulations, or is it driven by some of the regulations? So this is a great sum-up panel for that. And what I'm going to do is I want to set the context of the future, because we all work in this context. Sometimes we're not directly aware of it, but I think it's very important to know what that global context is. And generally speaking, you look at these global demand drivers to 2050. It's population increase. We're on our way to 9 billion people. What has not been directly talked about, I think someone alluded to it, is rapid urbanization. Across the world, for the first time, more than half the population of the world lives in cities. China has set a goal that this is a country that had only 15% of the population lived in cities just 2 generations ago, or 25, 30 years ago. They have passed 50%. Their goal is to have 85% of the population of the 1.4 billion people living in cities. And you can kind of think about what that means. The other trend that we see out there is a growing middle class, that across the world, the way the trends are, for the first time, we are likely to see half the world's population be middle class or middle income in some form. And then we see the climate change impact, which is coming along. You can see for yourself, I'm not going to read through the bottom 4 pieces as to what's happening as a result of that. But let's look at disruption. Because if those are the global trends, and that doesn't affect you directly, there's nothing more disruptive than the local event. It's flipped the other way, the local event is, an aspect of disruption. If your neighbor's house burns down, that's very local, versus talking about forest fires in California across the state. So we got 3 things here. You all know about drought. We talked about water. You all know about invasive species, and you've heard all the different aspects of how we deal with that on the pest side of things. You've already heard about the shrinking farm labor pool. Those are very disruptive events, and you've already heard the discussion and the specific questions asking about that. There's other kinds of disruption, and they will land from the meteor. Disruptive technology. I would just show a picture of Steve Jobs and say, here's Mr. Disruption himself. And we didn't know we had to have that technology, but he figured out how to produce it, and we had to have it. Incredible disruptive type thing to happen to us. And then we've already had this whole discussion, and I put that in there without having heard any of the discussion, regulations. So how do we deal with that? So for that, we have our great panel. And there's 4 people here. I will just briefly introduce each one of them. The bios are actually already printed out there. Lance Downey is the Chief Executive Officer of On-Farm Services. And he can probably tell you, if you want to ask a question about what the cloud is, he works in the cloud. It's that mysterious thing that nobody can ever explain. Terry Brasi, who's an instructor here at the Farm of the Future, and it's directly relevant to the discussions we just heard about how we train the next workforce. David Zaldalski, he's the director of the Center for Irrigation Technology at Fresno State, and deals with, of course, the most important issue, water, out here, and the various aspects of that. And Gabe Utze, who is the CIO for the University of California Ag and Natural Resources. And Gabe and I have gotten to know each other in the last seems like a couple of years, but it's only really months, right? Year or so, year plus. And so if you want to talk to somebody who's got one of the most innovative minds and instincts around, that's Gabe. So they'll come up in order, and with that, Lance, you have the stage.
Thanks, Robert. Besides cloud, if you want an advanced course, we can talk fog too. That's an inside joke. If you don't know what that means, it's not the Valley. It's a new technology class. So I'm a Valley born, raised guy. Grew up in Madera. My family farmed table grapes. Went to Fresno State and been in the Valley ever since. So I'm the unique guy that not the brain drain, typical that you lose people to other areas. On Farm is a company I founded almost 5 years ago now that helps farmers make better decisions, right? So I'll give you a quick breakdown on what we are so you have that, and then talk about a little bit about technology. So we work usually with larger farmers, almost exclusively in the specialty crop space. We have hundreds of farms in 20 states in the U.S. We'll be in Latin America this year, and a few other places. We integrate data. So there's been some discussions about data and access to data and use of data. So to simply think about what we do, we built a system that integrates information across the ag industry. So it doesn't matter where the data resides, where it came from. We integrate that information. We bring it into one farm management platform. We get from a scope of the amount of data we collect about 2.5 million readings a day directly from fields, right? So we're kind of in the big data space. And if you want to read about us, we've been picked up in a few places there on the bottom. This is not a commercial. So it's just a kind of a deeper dive into what we do. So we built this data engine that allows us to connect to the systems, either the pumps or the soil moisture systems or the weather stations or wherever that equipment or that data lives. We build a connector to those platforms. That's John Deere and Rainbird and Valmont and most of the sensor companies. And we have 50 already integrated today. We consume that data in real time. So we pull that data across in the cloud, across to our back-end system. We analyze it, and we provide it back to the grower to make agronomically focused decisions, how to farm. And so some of our customers are like Driscoll's and Anheuser-Busch and Wonderful Company and Ocean Spray and a bunch of others that use that information to grow better, right? So it's a very simple, hard to execute, very simple concept, right? So I think Robert started off really well. I think one of the challenges we're focused on, what we're excited about is, well, I don't know if we're excited about adding another 2.5 billion people to the planet, right? That requires 70% more food to feed them, both in population growth, but also in changing diets, right? China, India, markets that are growing in their middle class are changing. But the most interesting part of that is researchers suggest that most of that growth in food production is going to come from ag tech, right? So it's not going to come from applying more fertilizer or more water. It's going to come from either biology or from data science, right? So if you look at the global food market, if you look at the top 14 markets in the world, they produce just shy of $4 trillion in food a year, right? If you think of that growing 70%, right, from data and analytics and from biosystems, that's about a $24 billion opportunity a year in ag data, right? The challenge is that the data is messy, fragmented, missing in some places. We're seeing ag technology investment grow significantly. Farmers are trying to understand what the right technology is to apply to their farm to grow more, grow better, at better cost. And they struggle with data. Not necessarily the data itself. They struggle because they can't get good decisions out of the data they get. And I think someone mentioned earlier, they got a lot of data. It's like, what the heck to do with it is the question mark. So the challenge in the ag tech in particular is to turn data into information and then eventually decision, right? So how do we make a better decision based on the information we can collect? And that's driven by regulations. And the need to do this is driven by regulations, food safety, sustainability, as well as profit. How do we become more profitable in a globally competitive marketplace, right? So if you look at what's fueling this, what's fueling the growers' growth is device data, is data itself. And this is actually was a study done by Business Intelligence, which is a Silicon Valley style magazine that does typically not agriculture, does everything else. They looked at, and they actually source us, which I thought was kind of fun, in looking at ag data growth, right? And so if you look at here, we are here, the average farm gets about 100,000 data points a day, right? The average large farm. And they independently looked at the information using some of us and say that by 2035, the average farm will get about 4 million data readings a day, right? So data systems, the ability to manage this and process this data is going to be extremely important. It's growing at 20% a year. So given that this is a conference funded by West Hills, a community college, I thought a pop quiz would be really appropriate. So if anybody wants to guess, if not, I'll maybe do a show of hands. Does anybody have an idea how many ag tech companies there are in agriculture today? Any guess? 100? Anybody guess 100? Okay, 200. Okay. All right. Do you know how many there are in the Central Valley? Okay. So there's actually over 500 known companies in ag tech today in 36 different verticals. Okay? That's the known names. These are companies that you can identify. And this, if you look at the source, you can actually, this is way too big to read. I can't even read it from here. If you look at the source here, you can actually download this map, this data map of everybody in the industry. There's probably easily equal a number of companies that are in stealth mode or early mode that no one really knows about today. My point is that there's a tremendous amount of innovation going on in a lot of different spaces. And from a company that's in the Central Valley, looking at my fellow peers, there's a really small number in the Central Valley. So, which scares me when I think about ag tech. It scares me because where we spend a lot of time is in Silicon Valley, because that's where capital is for the most part. And that Silicon Valley's got technology, right? They've got talent, they've got capital, clearly, and they've got an appetite to build big disruptive businesses, right? And that means that they're going to invest, and they already are, investing billions of dollars to build ag tech companies that are either going to fail fast, right? That's their kind of motto, is you got to fail fast, change things, move it, keep it moving forward. Or they're going to disrupt agriculture from the outside. And they're going to keep at it until what they find works, or they give up trying, like in solar, right? So like green tech kind of dried up after a few years. They kind of gave up on trying to make those investments. The point being is that they're already trying to tackle the challenges that we're just talking about. And if we want to, I think Central Valley is uniquely positioned, talent, domain expertise, and so forth, customers, that if we're not leading this ag tech revolution, we're toast, we're gone. They're going to disrupt our marketplace, the marketplace we care about at our roots, and they're going to do it from the outside. And the big companies, the next Googles of the world and things like that, in ag tech, won't be here. They're going to be in San Francisco, or they're going to be in San Jose. So I think I mentioned this last year. I feel like passionate that we have to get serious about investing in becoming an ag tech center, right? Salinas is doing that in their ag tech investment. If we don't build the talent with the domain expertise and invest the capital in companies to take up these challenges where we're uniquely positioned, right? There is no richer ag marketplace in the world than the one we live in. Then the world we know and how it goes over the next 30 years is going to go someplace else. So that's my last slide. I leave you with that. I know there's other people who are going to talk about technology. But my challenge is to figure out, help figure out how we grow the talent, invest in the companies, help build the Valley as really the centerpiece of ag tech in the world. So.
All right, first of all, I'd like to point out everybody else seems to get up here and tell where they're from. So I'm an Iowa farm boy. So I grew up milking cows, cleaning pens, and driving a tractor. And I can tell you that driving a tractor was never been considered one of the most difficult jobs until now. All right? So now we've got all this new technology. okay? And we now need an educated workforce. Sure, we have tractors that drive themselves through the field, but that's an added level of skills and knowledge that we need. So I'm here to kind of present the perspective of technician education and how we meet the broad technology needs of the industry, how we replace the workforce with an educated workforce, which we've heard several people talk about, and how colleges become a promoter of technology. Okay? So I'm going to frame this up with a couple of cool technologies, and I'll say toys, because a lot of people, they love to fly these things, drones, actually unmanned aerial systems, okay? And they can be a toy, but we need to make them a tool. And the problem is that many people don't understand or recognize that there's sensors in these unmanned aerial systems that are taking infrared, near infrared, and various electromagnetic waves that we can use for decisions, okay? That part is kind of forgotten about, and that's what we need people to do. So what I want to point out is that this is a technology that has a lot of underlying skills that is needed, okay? It's not just going out there and flying them, collecting data, and then, hey, let's do something with it. There's a lot of very specific skills there. For instance, they need to understand electromagnetic wavelengths, what infrared is, what's near infrared, what is thermal waves, and how we do it. How do we actually take that UAS out there, and we're not going to do it at 6 o'clock in the morning, and we're not going to do it at 3 o'clock in the afternoon. There's a small time period where we're going to fly and collect that thermal imagery because of the reflectance and radiance and everything else. People need to understand that. Then processing that imagery, taking it out of the UAS, georeferencing it, calibration, mosaicing. There's a whole set of specific techniques that need to be done to that imagery if we're going to use it for decisions. Telemetry. Telemetry is the transfer of data wirelessly, okay? I had the privilege in my previous college of flying a fixed-wing drone, flew about 50 missions, and not once did I use a remote. I used my laptop, pressed a button to start the mission. I had the mission all set up, flew it, took imagery, came back, circled over top of me, pressed another button, land. Sounds easy, right? Okay, the planning of the mission and setting up the telemetry is, again, an advanced technology skill that these people need, okay? Not to be, hopefully not scary, but they now have something called drone deploy, where you have 20 or 30 of these UASs all up in the field at once, and they're communicating together through telemetry, and they're working together to take imagery, okay? If that sounds kind of disconcerting or scary, well, you got to understand the technology and realize, okay, we're not out there spying on anybody, and we're not killing anybody, so it's, you know, relatively safe. The next technology, I'm stuck. There we go. Okay, I'm sorry. Move a little fast. Okay, IMUs, inertial measurement units. These UAS have these small microcontroller chips in them as accelerometers, gyroscopes. That's what keeps the UAS even or a known position, okay, when they're taking the imagery. That allows us to create those 3D images or to georeference them. So again, if you don't understand what I'm talking about, that's right. It's an advanced technology skill. The people on the ground using this technology have to understand it. All right, here's another cool technology. 4 years ago, I had the privilege of going out to Pennsylvania and doing a technical review of a robot. Okay, this is a device that is designed, it's 30 inches wide, and it just automatically goes through the cornfield, automatically. It's not remote control. You set it up, and it goes by itself. It's got artificial intelligence, it's got sensors where it knows to move over to the next row, and the idea is that it is going to spray nitrogen on the corn whenever it needs it. Okay, you send them out there. When it needs a fill, it automatically goes out to a filling station, fills itself up with diesel, fills it up with nitrogen, and then heads out in the field. The idea is that 24/7, you got one operator, and that one operator is operating 20 of these devices, and they're just going back and forth through that field, providing the nitrogen as needed. Okay? Now, that's in a cornfield. The same thing applies to orchards or any other row crop which this fits down. And not only spreading fertilizer or nitrogen, but it could be sensing insects or sensing the product on the crop to evaluate it. So again, there's a lot of underlying technology skills. Such as telemetry, there we go, or GIS. Okay, the person has to understand geographic information systems. Okay, what they're doing is they're collecting the data, analyzing it, and interpreting it in order to come up with zones or variable rate application of the product. Okay, now I hear a lot about the interpretation, so I'm going to go off script here a little bit and point out that the working relationship between a technician and the manager has to be kind of defined a little bit. I heard Don Cameron talk about, okay, he doesn't want to be inundated with all this data, okay? And he shouldn't be. He's the manager. He's the decision maker. That's a technician's job. The technician's job, the one that's actually out in the field, operating the drone, collecting the soil samples, he's the collector of the data. He's the manager of the data. He's the analysis. He should turn over an interpretive map to Don, where Don can look at that, see all the data summarized, and say, hey, that's the decision I need to make. Make it happen. He turns it back to the technician, and the technician is the one that's actually putting it into action. Okay? That's the difference between a technician and the manager or the professional. Okay, sensors. This robot had sensors in it. Now, one purpose of the sensor was to be able to evaluate how it gets through the field. LiDAR and several other types of sensors can sense when there's a ditch, a big log, knows when it has to go around it, if it can go up and over it, but those LiDAR can also create a 3D image of the product, of the crop. Imagine sensing a pomegranate there and seeing if it's ready to harvest or there's some issue with it. Imagine it being able to identify a specific weed or a specific pest, and then doing something about it. Okay? Either shooting it with a product, or I've even seen a research where they're trying to use laser to kill an insect or kill a plant. Of course, at $5,000 a kill, that's a little expensive, but you know, at some point they'll get that down. Telemetry, again, we're talking about telemetry, communication between individual devices and between the operator. Cellular telemetry means that that supervisor might be back in his son's football game when he gets a text message say, hey, unit number 4 is stuck. Okay, you need to go do something or take care of it. High accuracy GPS, the cellular RTK. Again, this is going to take cellular systems to be able to communicate between devices and with the GPS. All right, so now we get to the educational needs. Okay, what's it going to take to train people in this technology? Okay, first of all, I want to recognize that there is a continuum of education, of technology education. Okay, we need 4-year schools, have to be working with 2-year technician positions. We need a pathway for students. They're coming out of high school, or maybe they're incumbent workers. They're coming through maybe a 2-year school, getting the technology, and then they have an option of either stopping there, getting a job, or continuing on to a 4-year school. Okay, but there's got to be that pathway through that continuum. Field-ready graduates. Now, my definition of field-ready graduate is when at my previous college, I had several students that they would go out on an internship. They hadn't even graduated yet. 3 months before they were to graduate, serve an internship, they'd go out to the job, meet with the owner of the co-op, dealership, or whatever, and sit down with them and said, okay, sorry, buddy, but our precision farming manager just left to go take another job. So we don't have a precision farming manager right now for you. However, good news is you are now the precision farming manager. Here's a cell phone. Here's the keys to your company car. Here's 3 calls from your first tech jobs. See you later. Okay? And you know what? They did it. Okay? Something we called fed to the wolves. But they did it. They did the job, and they were field ready. Okay? So that is possible. Training versus education. I want to point out the difference. Training means we take one of those displays and we teach the student, push that button. Okay? Companies do that all the time. Education, which should be occurring at the colleges, is why do you press that button? What happens if you don't press that button? What happens if you press the button and it doesn't work? Okay? It's that background that is needed that goes all around that equipment and the processes of that equipment, being able to understand that. And right along with that, then the critical thinking to be able to figure it out. Because we may only train or educate you on this device, but what happens when you go out in the real world and you're using this device? You have to be able to apply it. You have to be able to say, well, I can figure this out, I can figure this one out, I can figure that out, and I can figure anything out. Okay? That's the education. And it means not only those technical skills, but the thinking skills, the soft skills, those types of things are important. Now, again, I want to finish up. Hopefully I'm not too much out of time here. But I'm from Iowa, and I've been told, been here just since July, and I've been told a lot, well, you know, what works in Iowa may not work here. Okay? It's corn and beans. Yeah, I understand. This is pistachio, almonds, everything else. I love it out here. Just called my wife. It's like 20 or 30 degrees back in Iowa, so yeah, I love it here. But I'm not going to be here teaching precision ag classes, telling everybody how to use this technology in pistachios. There's no way I can do that. But the idea is that if we can train students to use the technology, if they understand what actuators are, how GIS works, how GPS works, they're going to figure it out, okay? They're the ones that are going to be able to take that technology and apply it to whatever crop or whatever job they have. Thank you.
Good afternoon. I've been assigned, I guess, the role of technology in agriculture irrigation, so that's what I'm going to speak to. But I am going to talk a bit about the growers' education and not so much the students. So I just put this together to kind of outline what I want to talk about. So what have we done, what's successful, what's new and promising, and kind of what are some of the challenges. And they might not be as apparent as you might think. Now if I can make this work. There we go. So I throw this up here only to show the blue and the yellow or gold curves. And the blue is flood or surface irrigation in California, and the gold is drip and micro. And that's at 2010. If we're out at 2016 now, drip micro is now the predominant technology in California for irrigating, and that's about 4 million acres. So the growers have adopted. 4 million acres is a lot of ground the road put drip and all that stuff on. So we're getting there, right? And there's a lot of reasons why, but just know that the predominant method in California now is drip micro, which has a lot to do with the almonds and pistachios, all the stuff, grapes you've been seeing, conversion going on. So this is a busy slide, but the point of all of this, I'm going to try to walk through water meters. A basic tool, every home has one now by state law. I would suggest maybe a third of all farmers have them on their wells. Not a high adoption rate. Not a new technology, but the definition of technology is one that's not widely used in your industry. And so my group, we try to promote water meters. And one of the interesting, there's a myth out there, I think, among some growers that if they don't have a water meter, they won't have to report to the state how much water they're using. And I suggest to you that the state won't use that as an excuse to not have you report your numbers. But more importantly, water meters provide a very important tool. It's kind of like your blood pressure. You know the health of your irrigation system. If the flow starts to change up or down, you know something's occurring. You need to go out and make some changes to your field. It's also a record of your water use. It's a real powerful management tool. So beyond government oversight, it does provide a lot of value to the grower. Weather stations, we know those are out there. If you know the weather, you can predict the water use. Soil moisture sensors, this is top of one coming out of the ground. It goes down about 4 feet, and about every foot it's got some sensor. It can tell you how the water's moving through the soil. And with some of the groundwater issues and other things, if water's moving beyond the root zone, that's a pretty bad thing. And again, what I'm going to talk to you about is collecting data, but collecting data for sort of 3 different reasons. And one's going to be for production, one's going to be for the regulatory climate, and one's for supply chain downstream, and why that's going to be important. We just heard about drones. Everybody's got them. We're trying to fly them around the university. We're within 5 miles of Fresno Airport. That creates a few issues. So, but we're figuring that out. And we also found out that St. Agnes Hospital has a heliport on top, and we're within 2 miles of that, and there's some other restrictions with that. So anyway, we're going to figure it all out, and we may not be able to fly as high as we like, but we'll be flying. We can measure plants directly, whether it's leaf or sap flow or whatever it might be, which is really sort of the holy grail, right? If we could measure every plant out there individually and know what its status was and what it needed, then we could actually apply whatever needs it might have. And then this last one, we saw some of the mapping stuff. What we're starting to see now, and I'll just this could be many reasons why we're seeing different colors, and this may be temperature, and this may be related to the soil type. It may be that all the red is in a sandy streak. And so what we're seeing now is the irrigation systems being designed not just as blocks, maybe this is 2 blocks, but in systems that are designed by the soil type, because once you can define the system by soil type, you can manage the crop much better. And it's really important for crops that are single pass, if you're collecting wine grapes or processing tomatoes, because if only 80% of them are ripe and 10% are overripe and 10% are underripe, that's a problem for the processor. But if we can manage by soil type and bring the whole field together so it's in the high 90s of ripeness, that's a big increase in productivity and water use and energy as well. So we have all the technology. I think that's not our challenge necessarily. Whoops, going the wrong way. That's maybe the challenge is my use of technology here. What am I not doing? There's the left arrow. Oh, why am I stuck here? Okay. There we go. So I like to show this one. This is a new planting of almonds, and you can visually kind of see that they all got sort of round, wet circles around them. That's the new system, and the new systems are very efficient. And every grower believes that their system is very, very efficient. This is a nice little bell-shaped curve that UC Davis did a number of years ago. I think it's 600 or 700 drip microsystems. They went out and they audited them. And so if you were all growers and you all had drip systems, and I said, who thinks their system is 90% above? Every one of you would raise your hand, because exactly your system was when you installed it. But the unfortunate part about life is as we age, we degrade a little bit. And so the average systems are not near, and this is drip micro, are not near as uniform and efficient as we would like to see. And so if you're trying to manage one of these systems down here with all the technologies we've shown you, all you're doing is well managing a poor performing irrigation system. So one of the things obviously is to get your irrigation system audited so that you know that you in fact are up here performing as new. But we have 4 million acres and they're all along this line. In fact, we've looked at some that are actually down in here 30%. And some of them, interesting enough, for corporate farms that you presume know better. And it's just interesting, the reasons behind that. That's a different story, but we could talk about that. But the message here, oh, and by the way, this is another grower I was out at. These are micro sprayers. This is about a 20-year-old orchard. And these were the original micro sprayers, and those, as the newer models got produced, they went to blues and reds. He swore that every tree got 10 gallons an hour, which is this one right here. All these other ones, when the irrigators would go out and when these things were stuck and unplug them, there's a little diaphragm, a little piece of silicone in there, and it blows out. they put it back together, the water's spinning, but now we have a high flow rate because we're no longer compensating for that pressure change. And he literally did not know that. He's an agronomist by training and not on the engineering side. And so simple information at the grower level, and this is a fairly, I mean, his yields are among, top 10% probably in the state. Just that bit of education. So what that tells you then is we're trying to irrigate our trees to the dry spot. What are we doing over here? Over irrigating, over fertilizing, and so you can manage your costs as well. So just education, again, basic education can go a long ways. So we've got two pieces to the irrigation pie. Apply it uniformly as possible. So we need some knowledge on corrective action if it's needed, and then applying exactly what the plant needs, when and how much. And so that's the irrigation scheduling part. And that can be done in a variety of ways. Again, our friend the flow meter, soil moisture, other things will tell you what's going on and when to irrigate. And again, you saw all the technologies that are there. So back to the education piece. We believe that we talked about 2,000 growers this last year as part of our effort. It's great to have the information and data, and you kind of heard that from Lance and others, but it has to be actionable. If you can't act upon it, it's useless, right? So that's important. The beautiful thing about millennials is that everybody's got one of these, and if I don't have an app for them in order to implement some actionable item, they don't want to hear from you, but if you got one, they'll use it. And not just being at the football game, but frost event, and turn on the frost protection from your bed, right? I mean, so you don't even have to, you can take care of that stuff. And then either incentivize, make sure it happens, and then you loop back, because whatever education you've just moved up on, there's something above you that you don't know. And so you continue that loop, and you continue educating. The last thing I wanted to say is I think the need for data is going to drive the adoption of this. And so we're going to see growers adopting it for three main reasons. Production, again, regulatory climate, we've got that, and supply chain. And the supply chain might be a Walmart saying, I want to know that the crops, the food that I'm selling in my store, that the resources were used in a reasonable manner, the energy, the water. I want to know the carbon footprint. We know now that pistachios being sold into Europe, they've got to report the carbon footprint on them, right? So it's coming. So the growers have three reasons to adopt data collection and data management. Any one of those will get them to the same place. So I think that's where we're headed, and probably sooner than later.
All right, I'm going to take Gabe Yahtzee here. I'm going to take a slightly different approach and really talk about how to catalyze some of this innovation in ag tech. There's been just wonderful examples throughout the day about the future of ag tech. How do you put it into action, and how do you mobilize the people side of things? So I'm going to kind of focus on that. So some great examples of all these various technologies. I pulled from a massive slide deck from one of our advisors, some of the technologies that have been discussed here today. So I won't go into those, and it's amazing technology, but the point I wanted to make, ag tech is not just all of these wonderful tools and services and approaches, but it really also is about people. And so I'm going to talk about a few different things here. One is this need that I've been hearing threaded throughout the day of having industry, academia, government, all working together. And really also, the great example from the very start of the day, Ag for Hire, capturing the energy and passion of our youth and how we do that. And then lastly, how do we value and grow our trusted social networks and really have those networks drive innovation. I think that's very important in the agriculture sector, because it's those networks that of trust that our growers are willing to try things, and you're actually able to mobilize some of these strategies in ways that outsiders from Silicon Valley or something are just not able to do. So just one, some of the things that we're thinking about in agriculture and natural resources. This is not a fully formed comprehensive strategy by any means, but these are some of the elements that we're thinking about that the university can play a key role in driving innovation. I'm going to focus on a couple aspects of this. and that is the Startup Incubation and Acceleration piece, UC AgTech Innovation Forum, and our competitions and challenges. So one of the key strategies that most of my UC colleagues I've been talking with our California State University, other university colleagues, are trying to figure out ways how can we better drive innovation through entrepreneurship. And at the university level, one of the key challenges has been really finding better, faster ways that we can really drive startups out of the University of California. And there's a recognition that our tech transfer folks, and if there's any of you in here, hello and welcome, but haven't always produced fast results out of the university to really help drive innovation out of the UC. I mean, creating patents and licenses is one thing, but startups, what about new budding entrepreneurs? How do we support them? And it's a problem that I think many in this room are tasked with solving around the state in our various areas. And one of the themes that we're thinking about is really not recreating the wheel with a siloed approach, but taking a partnership mentality all the way. And, thinking about what resources can we bring to the table. University of California A&R has research and extension centers all across the state, from very top of the Oregon border all the way down to Mexico. How can we leverage those regionally with partners who have other types of expertise, who have lab space, even commercial kitchen space for food-based businesses? And so really bringing together that partnership mentality, not recreating the wheel, and bringing together the finance, expert support from venture capital industry and finance. And they are willing, increasingly, it seems to me, they're willing to make the trip over here. And they're coming more and more out here and to different events that we're having, and to participate because they really see this is where the action for ag tech really happens. Marketing support, can't underestimate the value of marketing support. And just if people have new ideas, how do you bring those things to market? How do you understand if there's a market potential for those things? The logistical support, and then the scientific and research support to really understand, is this idea based on science or not? And so I'm going to talk a little bit more about that. So one example from the University of California Ag and Natural Resources is a product called Crop Manage. And Crop Manage, I'm going to go through these very quickly because I've committed the mortal sin of way too many slides and not enough time to actually talk about them. But Crop Manage is a UC A&R built application in partnership with a lettuce advisor out of Monterey County, Michael Kahn. And he has done some really great work in working with a number of UC researchers to really get at this question that many of you are also trying to solve: precision nitrogen and water management that's California specialized, not for corn, soy, and wheat. That would both help reduce water and fertilizer with the same or better yields, and provide reporting for regulatory purposes. So Crop Manage is the tool that we've developed. We've ground truthed it now in a number of different places with a number of different commodities across the state. We're recording 20 to 40% reductions in water and fertilizer with similar yields. Again, California specific, that of course links both nutrient and water management together because they are linked. Some of the aspects of this application, and part of what we're doing here is creating, this is part of the marketing aspect, really clearly articulating the value proposition, what the software does in a very simple, user-friendly way. And that's actually been a lot of the problem with bringing technology out of the UC, not user-friendly. So again, California specific, this particular product works we've worked with a number of different experts who are experts in these areas at UC Davis, UC Riverside, and other universities to come up with the specific algorithms that work for these specific crops. So we're working on that. And really, I'd say the main thing, we're working on interface, interface, interface. And it's all about, can anybody in the farm other than a highly trained technician actually use this application? This is one of the problems with the software now, is that it's designed by programmers and scientists, not ex-Googlies and Facebook and Apple people. And that's actually one of the biggest issues in ag tech, in my opinion. This other aspect of getting, youth, passionate youth involved and engaged in solving these problems. We talked, the perfect example, apps for ag, and there's been 4 apps for ag. UCANR partnered with the California State Fair to host this most recent one. We were calling it the Statewide Apps for Ag Hackathon. And this aspect of bringing students and professional programmers and UC, CSU, community college scientists together, industry, both growers, software, government, all coming together. It's just a rare forum where people come together over a definitive period of time to deal with a focused challenge, 3 days, a week, 59 days, whatever time frame you want to pick, that, kind of pressure cooker with all these people, not to mention the cash prize at the end and free pizza along the way, is critical. And so I'm a big believer, after seeing this last Apps for Ag hackathon, that this competition style format is uniquely, it should be a key ingredient going forward to ag tech innovation and any other kinds of innovation activities. And at the end of it all, try to identify those winners, and if they have the chutzpah, to help them start up and find those resources to help them do that. So this is the belt buckle. This is not our idea. West Hills pioneered this idea, but we love that theme. So this was the belt buckle that the winning team actually got from the last Apps for Ag hackathon. And the judges, we had 2 left over, and there were 4 judges. And so they basically kind of twisted my arm to order 2 more, so the judges got them too. But yeah, big hit. So Apps for Ag, running one of these things is kind of art and science. It's not that straightforward, and getting partners and sponsors is a key activity. But it's really not that hard to sell them once they see what you're doing and the value you're providing to the community. And I think increasingly companies are going to kind of run at these things to help sponsor them. So just, I'm going to blow right through this, but the winning team from the 2016 was an app called Giving Garden. It has 2 UC Davis professional programmers from the College of Ag and Environmental Sciences, and then 2 Silicon Valley types. So they work together. Ag for Hire was the 2nd place winner in this particular, on a new product they had as well. But now this woman, Dima, who has decided to become the CEO of this and actually quit her job at Flipboard to actually work on starting this up. So they have now taken this seriously, and what their angle is that gardening on the consumer level, people are interested in what to plant, what to garden, what to grow. And also to really, I'm going to skip over this, an app-based way to connect with your friends and neighbors to both give away your produce and find other produce to get. So they created a very professional website in 3 days. And they created this app that basically allows you to find available produce that you might have and want to share with your neighbors. And there's a whole bunch of ways they've figured out how to monetize this. There's a picture of their app. Some very, very nice photography built into that. So the point I want to make, I'm not going to read through these slides, is that part of the support that we're working on providing post-competition, helping them define their market space, and all of the things that if you go to Shark Tank, these are the things they're going to ask. the financial opportunity. How are they going to actually monetize this thing? And what is really the impact out in the marketplace in the community? So if you want to see more, there's the link to Giving Garden. So for 2017, we don't have a firm plan just yet, and thought this venue would be good just to bounce a little idea. What if we did some statewide multi-location regional competitions and hackathons that multiple universities and entities could take advantage of, and then we do the finals and judging at the California State Fair in Sacramento. So plant a seed for some of you who have already expressed interest in having some of these. We could hold them all around the state, and every region can have one, and we roll up to kind of a master finals in Sacramento or some other venue, but we've already have a nice partnership going with the State Fair, and it's a great venue to hold these things. So a couple other ideas just to finish out. We have a precision ag work group at the University of California Agriculture and Natural Resources. I'm finding it's been a great venue to bring together researchers from UC Davis, UC Riverside, UC Berkeley, other UC campuses, and industry who are working on really cool projects. It's mostly been about information sharing. I'd like to, in conversations with many of you and others, kind of move that into more of a UC Ag Tech Innovation Forum, and really think about how do we keep bringing together others like students, researchers, our growers, technologists, regulators, across the state, different parts of the state focused on ag tech. And so you have academia, all levels, growers and other industry, government, and finance. The venture capitalists is a great group to have in there as well. Goal there, share science, find partners, review technology, startup projects. I mean, if I hear another grower say, I get 1,000 calls a day from all these ag tech vendors and I have no idea what to do, I think a forum like this from the University of California that we pull together our collective wisdom and expertise and partner with others could actually produce something. So we could do just some ideas here, some Shark Tank style reviews for startup support, project grants focused on ag tech. I have in mind Gartner style reviews of ag tech products and services that are very consumable by the average grower in an industry. So, and last but not least, getting students involved early into some of these forums as they're going through their community college or undergraduate or graduate programs would be really critical. We've got some grand challenges to solve. Don't even have time to get into this, but networking, broadband access in rural communities remains a massive, massive challenge. This is my graph that I basically use to sell a project at A&R to upgrade all our networks. We have our UC campuses on the right there, which is their network speeds are ungodly fast, all the way down to your home network, and our field locations, including one up here in 5 Points Westside Research and Extension Center, have 1.5 MIPS, just ungodly slow. And this is, I know those of you who are growers are dealing with this kind of thing every day. You get best available technology out in your fields. So it remains a huge issue to solve, and we're working to try to solve it in different ways, but it's a tough one. And then, one of the things I heard in our Precision Ag work group that to me was the most impactful thing for me thinking about how to deploy ag tech and think about ag tech. Don't give me your confusing charts, graphs, interfaces, etc. And this is a grower talking to a bunch of UC professors. Give me a recommendation that I can trust and use. And really that to me is the mantra of how we should think about ag tech going forward is taking all this wonderful technology and really simplifying it down into Apple and Facebook level functionality that is really highly usable. So every technology should have APIs, the things that allow you to connect software and services together. They should all have those things. Open data repositories, as people have mentioned, is a tricky issue, but also common data formats. So all of this big data needs to be able to play nice together, and not everybody has the luxury of hiring a $200,000 a year data scientist. And really start to, as I already mentioned, apply Silicon Valley design to UC science. So I'll just end with this. This is Giving Garden had this in their presentation. I loved it. I thought it would play well with this audience. From Michael Pollan, shake the hand that feeds you.